Hello, everyone. Welcome back to episode 2 of the Python series, introductory series. Hopefully, everyone's got Jupyter Lab working from episode 1. So today, we're going to be talking about Pandas. The Pandas is probably the one package or library that you guys will use the most, not only in this term's stats tutorials, but in next term's projects and probably for any form of data analysis that you undertake. So yeah, let's get started. So in order to demonstrate Pandas, we're going to be playing around with a particular data set, and it's called used cars. So this is just a text file that shows the data. Can't really do much with the text file. And yeah, we're just going to play around with it using Pandas and show off some of the things that Pandas can do. I've already written some code down here. Excuse me. So this code, I like to call it boilerplate code, kind of because you just copy it and paste it and use it whenever you need. So all of the stuff that I'm highlighting right now, it's boilerplate code to turn a text file into a CSV. So turning used cars into a CSV. For those who don't know what CSV are, comma separated values, it's a type of file that you find on Excel all the time. So a lot of Excel files are CSV. So when you do your project, if you get an Excel file as your data set, you kind of don't need to worry about all of this. But for this particular case, we do. So if I just really quickly go through it, we're going to import JavaScript, as I mentioned about importing in episode 1. We're going to import string.io. We're going to do a bunch of stuff. We're going to turn it into a CSV. So the first thing we're going to do after that is import pandas. We're going to import pandas as PD. So from now on, anytime that you see PD, it's just short for pandas. And we're going to load up the CSV, which is pretty much the used cars text file, onto a variable called cars_dataset. Simple enough. Also shout out to Dora for getting all of the setup code ready for this. Let's go through it really easily. Yeah, let's take a look at what cars dataset looks like. It should look very similar to the text file. And yes, it does. Except, obviously, it looks like a really pretty table, but this is what we call a data frame. I think I might have briefly talked about data frames in the last one. I didn't really mention what they were. Data frame is the data structure that we use on Pandas. It's like the go-to data structure. It looks just like a table, except it has a few distinct features. You access everything through the column. So for example, this particular data frame, which is called cars dataset, it's got 6 columns: the column year, column model, price, mileage, car, color, and transmission. And it's also got an index for each of the rows. So it's got 150 different rows and 6 separate columns. And we're just gonna mess around with it. So the first thing we're gonna do is try and get individual columns out of it, because maybe you're only interested in the year and how the year works. So to access a particular column, you take the data set. I just hit tab to autofill. And in square brackets and in quotation marks, you put the column name. So if I put year here and I ran my cell, I would get all of the years in its own structure. We call this a series, which is like one column from a data set. Yeah, if I wanted to get the model, instead of typing in year, I put model here. And it just gives out different model names. Cool. If I wanted to get maybe a couple of columns, so I kind of wanted to get the year and model and price, let's say. I didn't really care about the rest of the columns. Then I would just put another square bracket inside. And I would just separate the name of the columns with a comma. So it'd be like a list of column names, if that makes sense. We haven't really talked too much about lists, so if that seems a little off for you, not to worry. I'll probably make a video on the list comprehension soon. So we're interested in model, price, and yeah, it doesn't really matter. That's just cool. So now we've got a data set just with those 3 columns. Oh, data frame just with those 3 columns. Now that we've got that, we can show you guys how to make a copy of a data frame. So there is a really handy function straight off like data frames called copy. I'm just going to print it here. So pretty much, if I want to make a copy of a data set, I put the name of the copy, I put the name of the data frame, and I do .copy deep equals true. Deep is kind of where it gets stored in memory. So cars dataset 2 should look exactly like cars dataset 1. The difference is it's a completely different variable. So maybe you want to keep cars dataset aside and you want to mess around with a copy of it and see what happens without like ruining the original dataset. So that's why you want to make a copy. Just something handy. The next thing we're going to do is learn how to insert a column into a data frame. So if I just copy this in here, I'm also being very lazy and just copying stuff in. It's pretty easy to type out, but this code will be available to you if you want to use it for the projects anytime. So that .insert function actually allows you to place a column anywhere in your original data frame. So in this particular case, we're going to look at cars dataset 2, which is just a copy of the original. And we're going to insert the column price 2. So this is the name of the column, well named. And we're going to put it in location 3. So for those who are a little unfamiliar about Python indexing in general, not just for pandas, but for any package, indexing starts at 0, which pretty much means the first column is like the 0th column. We always start with year as the 0th column, model as the first column, price as the second column, etc. So if we want to put it at location 3, we're really saying we want it to be the 4th column. Cool. And then what do we actually want to put in the 4th column with the name price 2? We want to put the price column from cars dataset, but we want to multiply it by 2. So that is literally all we're doing here. So let's just see what that looks like. Show what it looks like after. Cool. So now the 4th column, it's already done. Oh, it's because I tested the code earlier. That's why it's happened twice. Not to worry. But the 4th column, as desired, is price 2. And if it's not super obvious, it's exactly double price 1. Maybe I want to insert a price 3 as the 2nd column. And I want to maybe halve the price column from earlier. So if I do this, I'll get price 3 and it should be the 3rd column and it's exactly half of price. I can make it whatever. I could put a completely different data set here and slip it into the data frame, whatever you want. That's how you insert stuff in. Hopefully that's handy. Next, we're going to go back to the original cars data set because we messed around with the original. No, we're not. We're going to do one more thing. We're going to use a function called getDummies. Now, while not obvious, this actually generates a dummy variable for a particular column. So our data set is cars data set 2. The column that we're interested in is year. If we just play this, take a look at what it's done. So obviously we've got our years. We've got 2000, 2001, 2002, 2003, etc. And it's created a column for each year and turned that column into a dummy variable where if the car is in that year, it would be 0. If the car isn't in that year, it would be 1. So just as an example, the first row, the year was 2011. So if we go up to 2011, we'd get a 1 there, but all other columns would get a 0. Cool. Hopefully that's straightforward enough. I do understand it might not be immediately obvious why we're doing this. making dummy variables is super handy for if you want to do like regression later on, especially if you want to regress with categorical variables. Another topic that we will talk about in the stats tutorials. Getting dummy variables, super helpful. So just keep that in mind. The next thing we're going to do, and there is just an endless amount of things we can do on Pandas, but we're just going to showcase a few more. We're going to get the length of our data set. So this one, not particularly necessary because it already shows it at the bottom. But if we really want it, just type in len, keyword for length, the data frame that we desire. It should put out 150. Yes. Cool. Right. Now we're going to get into some stats, some handy stats. So some of these columns, they are numerical. So we can find stuff like mean, median, mode really easily. Straight off the bat, let's get our data set rolling. Which column do we want to find stats for? Let's do it for price. So if we want to get the average price, all we would do is, is that right? No. Cool. So that is the mean of our cars data set price column. So it's kind of like the average price over all of the years and over all of the models. If we wanted to get the median, we would just do that. And it'll give you the middle value. It'll order it from smallest to largest, give you the middle value. What else? We could get the minimum and maximum price, the cheapest or more expensive car. I believe the keywords for that are mean. Cool. And the next keyword for that is max. Nice. So there's a car for $3,000. There's a car for like $21,000. That does look about right. Awesome. What else can we do? Oh, yes, this is super helpful. So we can actually filter through this cars data set. This is probably the most useful thing you'll do in any data frame. And we can look for certain traits in our data frame using what we call a Boolean function. So a Boolean function is just like a yes or a no situation. So we'll start off simple. Let's say we have this big data set, but we only want the stuff in the data set from the year 2011. The way we do this is we say cars data set, we put square brackets, and inside the square brackets, we put a statement that we want to be true or false. So we'd say the cars data set column year, and we want this to be 2011. Yeah, and we use a double equal sign because it's like equality. So yeah, now we've got all of the different data points where the year is 2011 specifically. Maybe instead of that, we wanted all of the data points where the model was SES, let's just say. Oops. So I want to do model, and I want to say it's equal to. Again, if this seems a little unfamiliar, when you put it in quotation marks, we call it a string. So like a word or a letter or something like that. That's all quotation marks stands for. So yeah, these are all the SES models across various different years, whatever their price, mileage, and whatnot are. We can also get pretty fancy. We can say that we want our cars data set and we want the prices to be within a particular range. So let's define that range first. Let's say our minimum price that we find acceptable is, I don't know, like 1.5 times the cheapest car. It was like around 3,000. Let's just make it like 7,000. Doesn't really matter, make it whatever. And let's make our max price of 15,000. So we want a car between $7,000 and $15,000. We want to see which cars are available. All we do is we again take our cars data set and we put a Boolean thing inside the square brackets. This time we would say that the price column has to be less than our maximum price and it has to be greater than our minimum price. So our price column has to be less than price. And this is the key symbol for and. So we want two different truth statements. We want it to be greater than our minimum price. Just gonna copy this. Cool. And if I print this out, it does not give us anything. Why is that? Of course, because I got to put it in brackets. Apologies. Let me just bracket out these two things here. Sometimes you get errors like this, and usually it's just something silly like bracketing, or you spelled something wrong. That tends to be a lot of programming stuff. But yeah, now we've got all of our kind of data points where the price is between $15,000 and $7,000. So it's this little chunk here. Cool. Maybe you wanted all cars with a color of silver. Maybe you wanted all cars with a color of black. Maybe you wanted all cars that are silver or black. I'm pretty sure you can do all of that with this kind of idea. Hopefully that's okay. Again, you can always practice this in the tutorials or in the projects. We're always here to re-explain it. Next up, we are going to make a pivot table. Hopefully people are comfy with pivot tables. I hope. It's like, it's a thing that I first learned on Excel that like groups certain columns in certain ways. So let me just copy the code over and we'll talk through it. So something familiar, we are pivot table function from Pandas, which is PD. So if you want to access a particular function, you do PD dot and then the function name. The data set that we're accessing is cars data set. Now our indexes are model and year. So we want to look at model and each particular year. So for model SE in 2009, model SE in 2010, etc., etc. We want each of those as sort of like a pairwise thing. And we want to be able to look at the mileage and price for like an SE model in 2009. And what exactly about the mileage and price? Well, we want to look at the average mileage and the average price and the number of cars in that particular year. Yeah, hopefully that makes sense. So this aggregate function, it kind of tells us what we're after. So if I hit play, obviously I want to look at table one. Cool. So as you can see, for model SE and all of the years, we've got the average mileage, we've got the average price, and we've got the number of SE models in that particular year. This is like a really, really handy way of summarizing a big data frame into a really like summarized column. We can see for SEL, cars in 2009, 2010, 2011. And for SES, there's cars through all of these years. Okay, cool. All right, what is next? Yes. So a handy column, a handy function, purely for aesthetics. So sometimes we do things so other people can read our code, or we can come back and look at our code and know what we're doing. We can rename columns. Seems like a pretty standard, straightforward step. There is a lovely function called rename, and it just does it for you. So table 1, we want to rename mileage into something that's more representative, aka average mileage. Price into something that's more representative, like average price, because that's what these are. And then year, this is the count. So we can say count of year or something like that. And that is what we've named it here. Dot rename is the function. You just have to do columns equals, and then list the original column name and the new column name, etc. If we look at table 1 after this, there we go. Our table is a lot more readable, which is nice. The next thing we're going to do is add a total row. Actually, no. We are going to make our pivot table even better. We're going to add some more features to it. So here's a big chunk of code here. Again, I'm a bit lazy. I haven't typed it out myself, but we can work through it. We're going to use a function called group by, which I think is one of the slightly more advanced, but one of the most helpful functions that Pandas offers. Essentially, all it does is it groups certain things, certain columns in a way that you desire. So in this particular case, we want to take our table 1, which is this table right here. We want to group by according to the model. So according to SE, we want to group everything else. So for SE, what do we have, etc. For SEL, what do we have? And for SES, what do we have? Now, we use a lambda function, which is kind of helpful to apply multiple functions in a row. If this feels really complicated, don't stress. There's easier ways to do what you're after. But in this case, we use a lambda function to find the average mileage, the average price, and the count of the year. So the average mileage, we're going to take the mean of the average mileage for each model. So we're going to average all of these numbers for a particular model. We're going to average all of these numbers for SEL. We're going to average all of these numbers for SES. So that's this command here. For price, we're going to do the same thing. We're just going to average the price for each model. And for count of year, which is a new column, we are going to sum up the number of cars. So what that's going to tell us, if I this, is it's going to tell us the average price of an SE model across all of the years, which is about $65,000. Sorry, the average mileage, the average price, which is about $10,000. And there's a total of 78 cars in our data set with the model SE. The SEL column, we've got an average mileage of about 27,000, and we've got an average price of about 15,000, and there's 23 cars. And for SES, same thing. Average mileage 63,000, average price 10,000. We've got 49 cars in total. So these are our handy summary tools. And again, when you get your own data sets, you can come back here, steal this code, however you want, whatnot. Cool. Hopefully that makes a little bit of sense. What do we have next? We don't have much else. Kind of like what we did earlier with getting all the values from 2011, we can get just the total columns using the following commands. So this line of code, it actually says we want to create a new table, table 4, which is table 3, but we want to take the index of table 3 at level 1. So for clarification, the index of this table is model and year. And we talked about how the indexing starts at 0. So index 0 is model, index 1 is year. So we want the index 1 to be total. So we want this column, we want this column, and we want this column. And then if I obviously show table 4, which I forgot to do every time. Yes, we just get the totals. Total this word total, it's a bit misleading. We get the average mileage for SE, average price for SE, and count of SE cars in a nice summarized table. If we want to get, let's say, all of the, if we want to get just the details for SE, then we pretty much do the same thing, except we look at level 0. So we want to look at the index of level 0, and we want it to be SE. So we only want this to be SE, and we ignore everything else. And if I show this, and yes, we've only got the SE model data. And of course, for the year 2000, we've got the average mileage, average price, number of cars, etc. Okay, the very last thing that we've got, which is also a very helpful function, is the correlation matrix function. So we've named it core matrix. Really, it's your data set and then dot CORR bracket. Now, before I pull that up, let's look at our data set again. So our data set has got 6 columns. So if I print this, what it does is it prints a correlation matrix. So it takes the 3 numeric columns, because it's a bit difficult to do this with categorical columns unless you do pd.getDummies to change it to like a number. But it takes the 3 numerical columns, which is year, price, and mileage, and it compares their correlation. So for those who have done a little bit of stats before, hopefully in math in high school, the correlation coefficient, R, it tells you how related they are, or how easy it is to get a linear relationship between the two. So as we can see, a correlation between year and price of 0.84. Obviously, 1 is the highest. So this means there's a pretty good positive correlation between the 2 variables. And there is a negative correlation of negative 0.76 between year and mileage, which means it kind of looks like this. We'll talk about correlation in the first tutorial if anybody needs a refresher. But yeah, hopefully that is a description of some of the functions that you can do using Pandas. I know that it might have felt a bit rushed and a bit like, what's the point of this? These will be really helpful in the future. So just trying to get you guys comfortable. The other thing, when I would do my programming, if I wanted to get the minimum of a data frame, and I don't remember the function, the only way I do that is by Google. So all of these are really easy to Google. If you want to get maybe you've got a data set from your project and you want to get the standard deviation, just search up Pandas data frame, how to get standard deviation, and there will be documentation from the Pandas page, or someone will have done it on Stack Exchange and show you exactly how to do it. So do not be afraid to Google everything. That is a lot of coding is just Googling. Hopefully you guys enjoyed that. And yes, I will be back next to show off NumPy. That'll be my next video.